Hello and welcome back. So I will continue my series of videos about the covenants, and as we discovered yesterday, there are some really good sources which I will continue to use from now on. And the first one is this covenants.info website, which is a covenants wiki. And as we have already explored, there's an overview section, a proposal and use cases section, and well, they are really well organized. There's this statical website, which is what we really needed, and there's a lot of reference to external resources. One of these is this chart where we have the representation of the support which several developers are demonstrating for different techniques of covenants. And then we have Rusty Russell's website and blog, where he discusses many topics relative to Lightning and script and covenants, which are, as we have already seen, they are really connected topics. It's really difficult to separate them, and it's interesting to observe the work that Rust is making in, well, a lot of he's working a lot of fronts. He analyzes covenants techniques, and he's working on Lightning. So there's a lot of material we can use. And then we found some other websites like this one, which I did not explore, and is something that Andrew Polestra written. I'm not sure if he's the only author of this website. It looks like yeah, it looks like his own website, and he also published something interesting, like these two articles about the cat operator, which I remember is the concatenation operator, which would allow to expand and to enforce many other operators, so many other covenants techniques. Okay. Yesterday I started reading this article about the taxonomy which Rusty Russell tried to create, classifying the different approaches which we have when trying to analyze a covenant solution. And he is somehow demonstrating how in reality the different covenants are recombination of simpler covenants, which in the end are just operational codes. Therefore, I understood, reading this article, which I would like to read again in the future, I understood that I really need to study script and operational codes. And for that, for this reason, I think it may be useful to reread or maybe go for something similar to Mastering Bitcoin by Andreas Antonopoulos. And yeah, I'm not sure if it will be the case to study that material in this context, in this series of videos. Maybe I will separate it as those aspects are useful not only for this series of issues. Therefore, I will just, in this series of videos, I will just continue principally reading this website. So the script and operational codes, static sessions will be isolated in other videos. So yesterday we have seen this really good introduction which explains that the nature of this website, and then it immediately starts saying what are covenants, and they explain the etymology of this word, and they explain that is basically conveying script language and transactions to talk about themselves, to do operations which involve themselves. So transaction introspection is what we want to achieve with covenants. Script already has certain introspective capabilities. We have seen that. And then there's also the invitation to contribute to this website, which honestly I'm really considering maybe my first contribution to one of my first contribution, because I'm moving on parallel tracks to contribute to the whole project. Okay, sorry, I had some issues with my allergy. Therefore, we can continue. So in this table, we can see these, which are covenants, techniques, proposals, or implementations, and the use cases with which they have synergies. And here we have this glossary for particular cases, but in any case the sense is, for example, any prevout has a synergy with lightning symmetry. Then it has not a synergy with volts payment. It has somehow, it says half, which I'm not sure what does mean, half synergy, but it has a slight possibility of being combined with ARC protocol. Then we have state chains, space chains, and so on. And then, for example, in case of CTV, we have again CSFS as a special status, which is yes if combined with check sig from stack, because CTV has different grades of implementation, and check sig from stack is one way of integrating it, because there are several ways of doing it. So what we'll do now is, instead of going to watch as this inspecting these synergies, we are going to study the use cases and the techniques first, and then we come back again to this table. So sincerely, I feel that it's easier to start from the use cases. I somehow feel that they are more accessible, and yeah, we'll start from the use cases, and then we'll go to have a look in the proposals. I think it will be an iterative work, so we'll go from the use case back to the proposal and so on. So I see here lightning symmetry, transaction templating, symmetry. Well, let's start from transaction templating. So, okay. let's see how long is this. So what I like from this website is that they are really concise, and they give you some external references to what may be interesting to study deeper. So here we already have a link to the proposals which have a focus on enabling transaction templating. Okay, so transaction templating is more of a generalization of various use cases than a concrete use case. We want to refer here to the use of covenants to construct a series of either entirely or partially pre-specified transactions that is committed to in and output. To in and output. Okay, I'm not sure about the meaning of this to in and output. Okay. So to receive an output, maybe. Similar constructions to these are currently possible by pre-assigning the transactions. The drawback of these is that large signature and public keys have to be put onto the transactions, and that the entire transaction has to be specified upfront. Proposals for better transaction templating constructions will mostly focus on being less costly and more flexible with regards to how complete the specification of the transactions has to be. Generally, transaction templating is useful to reduce interactivity in various multi-user and off-chain protocols. Okay. Okay, sorry, I'm back. The allergy is killing me. So we had a look at the superficial definition of what transaction templating is. So it's just a category, it's not a specific use case. It's a category in which we have all the proposals, all the use cases, which want to improve templating constructions, making it less costly and more flexible. Generally, transaction templating is useful to reduce interactivity in various multi-user and off-chain protocols. For example, in Lightning, when managing liquidity, users will need to exchange messages in various forms. Therefore, with transaction templating, what we can obtain is less conversation and more predefined protocol. Now, as I see that this is kind of short, I would like to see if we have just another resource, BTC transaction templating. Let's see, okay. Let's go and see, for example, if in delving Bitcoin, let's see if we can find something like templating. You've performed this action too many times. What the fuck? Man, what the hell? Are you serious? What the hell, bro? Let's go fucking Google. Let's put this as domain. And let's fucking search what I want. Transaction templating. So post signature cross input scripting. Let me look. Let's use the help of an LLM in BTC vocabulary. I found out the phrase transaction templating. Do you have any idea what I am talking about? So transaction templating can refer to how scripts follow standardized templates, which makes them standard transactions. These are templates like pay to public key, pay to script, pay to witness. The network mostly relays and mines transactions that follow these known templates for efficiency and security reasons. Okay. I'm surprised by the quality of this first observation. I mean, it's something obvious, but yeah, first of all, we have already, let's say natively, not natively, but like historical convention, we have these type of templates of transactions. So in wallet software or development environments, transaction templating is used to construct a transaction. Sorry, I again have problems with my allergy, so sometimes I will have to stop. Back again. So template transaction in development and automation. It can be used for constructing a transaction template with placeholders for input, outputs, and fee. Sign the transaction later after gathering user approval or secure keys. This is useful in hardware wallets, multi-signature setup, or partially signed Bitcoin transactions. Then we have template matching in consensus rules. To enforce consensus rules, if a transaction script doesn't match one of the expected templates, it may be rejected as non-standard, even if it's technically valid by consensus rules. This protects the network from spam and overly complex scripts. Okay, TLDR, transaction templating, generally refers to using predefined structures or formats for transactions, either in scripting, network policies, or in software design, allowing for easier construction, validation, and signing. Okay. Now I will think. Okay, considering what you shared with me, I may assign to the second category those type of templating techniques which may be used to reduce interactions between Lightning users when opening, managing, closing a channel. So okay, the LLM agrees with me. Those kind of templating techniques will indeed fall into the second category, development automation, level transaction templating. In the context of the Lightning Network, transaction templating plays a key role in channel opening. So for funding the transaction, a channel is opened with a 2 of 2 multi-sig funding transaction. The funding script and transaction are templated before broadcast. The structure is known ahead of time. Each party prepares signature based on shard templates, reduces interaction overhead since everyone knows what to expect. Commitment transaction, state updates. These are not broadcast immediately but are pre-signed and ready to be used if the channel is closed unilaterally. They follow a template which outputs like HTLCs and to local remote outputs. Both parties use transaction templates to pre-sign and validate these updates efficiently. Cooperative or force clause. A cooperative clause uses a simple mutually agreed template to withdraw funds. A force clause uses the last valid commitment template already prepared. Enhances security since pre-signed transactions can be verified against known templates. Facilitates interoperability across Lightning implementations. So then we have PSBT plus templating. PSBT, isn't it? No, it's not one of these. What the fuck is PSBT? Partially signed Bitcoin transactions. These partially signed Bitcoin transactions are often used in templating to coordinate signatures securely between multiple parties, especially with hardware wallets or offline signing. Let's talk about transactions, templates, the transaction templates. At this point, I have many things in my mind which I would like to explore. And I don't want to go too much on script, transactions, and those things like operational codes, which in this case are not the center. They are things which I should already. I need to arrive here prepared, and I'm not. So let's see. How can I continue to explore strictly Covenants techniques without going too much in these, which is something I will need to go for after. However, okay, we have an idea why in Lightning it's so important to have transaction templating. Okay, so these proposals are those who can enable transaction templating. CTV and TX hash, which in our summary table are here. And in BTC Optech, when going to topics, covenants, we have sig hash any prevout, which is the first, the APO. Then we have check sig from stack and check template verify. Check template verify is CTV. And this one, check sig from stack, is the famous CSFS, which derives from various uses of check sig methods, which are different ways of checking signatures, checking sequence verify. Okay, so I think that it's necessary to I will start with CTV. And TX hash combined with check sig from stack will be an alternative to check template verify and APO. Then there's this, what? The cat is not available. Let's see others. Cat. Okay, so they didn't write it yet. Okay, so we started from transaction templating. Now we have to have a look to CTV and TX hash. TX hash requires to have a look to CTV any prevout, and I will say also check sig from stack, which we don't have here, so we'll go into BTC Optech. Go to topics, covenants, check sig from stack. And then we have the cat proposal. Oh man, it's cat with double T. Come on, we can do better. Oh, look here. So in reality, in the GitHub, we have a page for cat, but it's not published. However, we can have a look at it here. Okay, so I will just have a short pause and then we continue with these pages which I opened, and let's go. So CTV, operational code, check template verify. I have another curiosity which I will study deeper in later sessions, but I want to see if we have a list. Cryptography, flow control, constant, stack, bitwise logic, data manipulation, and arithmetic. We have more categories here. Cryptography, log time, reserved words. Splice, stack, flow control, constant. Wow, didn't know about up L shift. Okay, so we have a lot of operational words, opcodes. And we have also some examples like standard transaction to Bitcoin address, which is paid to pubkey hash. This is usually not represented like P2PH. Probably unspendable prunable outputs. Okay. So let's see, opcoins, opcodes used in Bitcoin script. Let's see if we can see it smaller. So constants, flow control, stack, data manipulation, bitwise logic, arithmetics, cryptography, use NOP opcode identifiers, pseudo words, reserved words. Let's see if we can find, for example, what was that? Cat? Op return. And do we have opcat here? Yeah. Concatenates two strings. And then we have op return, which is flow control. Okay, it's interesting to have the opcodes in mind, like a place where we can check opcodes. Actually, I will keep it open. Pin. Or maybe unpin and add to new group. Okay, therefore, we were going to study some proposals, as we have seen from transaction templating, that it's relevant to study CTV and TX hash. In order to study TX hash, we need to study also any prevout and checksig from stack. And then the combination of TX hash and checksig from stack results in something like CATT. Now let's start from CTV, which looks like one of the most important proposal. Is a proposed new opcode that takes a commitment and requires any transaction executing the opcode to match the commitment in the following fields: its version, log time, signature script, number of input sequences, number of outputs, and the location of the input being spent with the spending transaction. This basically allows an output to specify how its funds may be spent, a design known in Bitcoin as Covenant. CTV has been suggested for use with a variety of protocols: congestion control transactions, channel factories, joint pools, vaults, DLC efficiencies. Then we have alternatives to CTV, criticism, composition, history. Nice. Homepage of utxos.org. So the first link we have here is the BIP 119 190. So another thing which I feel that I need to study in order to comprehend all this stuff is the whole library of BIPs. So if we go here, new group, BIPs. let's see if we have a better representation. Okay, yeah, we have this one, which is what I was looking for. BIP purpose and guidelines. BIP process revised. Nice. People wishing to submit BIPs first should propose their idea or document into the mailing list. Do not assign a number. Read BIP2 for the full process. After discussion, please open a PR. After copy, editing, and acceptance, it will be published here. We are fairly liberal with approving BIPs and try not to be too involved in decision making on behalf of the community. The exception is in very rare case of dispute resolution when a decision is contentious and cannot be agreed upon. In those cases, the conservative option will always be preferred. So those proposing changes so I can observe that not all numbers are occupied, which is something curious, but I think it's not really important now for me. Then we have a series of numbers which are, yes, are occupied, like 10, 11, 12, 13, for, yeah, here we have all of them. For 20 series, no. Then we have 30, which looks like complete. Yeah, then 40 series is complete. 50 has some holes. 60 looks like complete. 70 complete. 80 complete. Nearly. 90 not complete. Okay, so here we start. So they're not ordered for a specific meaning, if I'm not wrong. Check template verify by Jeremy Rubin, standard draft. So it's really well developed. We have a lot of material. Okay. I will add these to a new group. Okay, therefore we have this website, next gen smart contracts for Bitcoin. Is this Jeremy Rubin? Let's have a look at this video.
Welcome to utxos.org, a website devoted to BIP119 Object Template Verify. BIP119 introduces a new opcode that will dramatically enhance Bitcoin's smart contracting facilities and capabilities. An example that I like to give is wallet vaults like the one you're looking at behind me, or a time-release program that can protect your sats from would-be hackers. That's not all that you can build with Object Template Verify. There are numerous examples listed on this site, like non-interactive channels and batch payments. Well, what are you waiting for? Dive right in and learn more about BIP119 right here.
Okay, so here we have the specification in GitHub. So yes, that guy is Jeremy Rubin. And here we have the implement BIP 119 validation. So here we have already a pull request, a PR, which Jeremy Rubin wants to merge 23 commits into Bitcoin 24, blah blah blah. Closed. Okay. So sorry, I've been silent for a while trying to read through the BIP and PR review. Yeah, I was watching this PR trying to understand how others reviewed it. And here we have some reviewers. Let's have a look, for example, if there's someone I recognize like AJ Towns, Glocho. I will watch at her review. We went looking everywhere but couldn't find those commits. Huh. What the fuck? Let's have a look at, for example, Duncan Betts, which requests. Yeah, like I'm curious at this point for requests. Remove string exclusion from local check. Wallet, RPC. Let's have a look at these. Okay, whatever. So here we have the discussion of the implementation of CTV. Let me have a look at CTV. So here we are. This guy has a pull request titled like this, reg test only. I'm not really secure what this means. This has been done a couple months ago. So the guy moved the conversation here. Okay. So now maybe we are kind of more prepared to read the first paragraphs. So object template verify is a proposed new opcode that takes a commitment hash as a parameter and requires any transaction executing the opcode, include a set of outputs that match the commitment. This makes it possible to create an address that specify how any funds received to that address may be spent. Secure the bag. The proposal initially focused on the ability to create congestion control transaction where a spender pays a single address using CTV, which, when confirmed to a suitable depth, then assures several receivers that they can each be paid. This two-step process can probably be used anywhere. Payment batching is an option, but it can likely reduce fees even further than payment batching. Congestion control. Okay. Later version of the proposal placed greater emphasis on other contracts and covenants that could be created using the new opcode, such as the ability to create channel factories, vault and conjoin, blah blah blah. Other authors have mentioned that the new opcode could possibly be used to allow users to trustlessly pool their funds together in a single UTXO. Okay, the original proposal also emphasized other contracts and covenants that could be created using the new opcode, such as the ability to create channel factories. Okay. On the criticism of the proposal have focused on it being too specific to the congestion control use case rather than providing a generic covenant capability. Check template verify. I would like to have like a schematic explanation on how it works. Here there's a conversation about reaching consensus on a first step towards the covenants. Okay, I think my ideal roadmap looks like this. Enable CTV and check SIG from stack as soon as possible. Great script restoration, which is a work that Rusty Russell is doing. Oh, yeah. Since Bitcoin users don't use the protocol directly but app developers do, when they are building the application on top, it's hard to evaluate the utility of different proposals. On generalized governance. careful first step. Okay, so here we are having an argumentation how to what's the best succession of deployments and restoration of opcodes. Both of them stay useful in the scenario of further upgrades towards generalized covenants. Wow, this is a nice article actually. And I will put it in my covenants collection. Wow, nice answer here. So this is a really long conversation happening here. Let me see how this works. So this goes from March 10 to May 6, which is yesterday. Okay, however, I saved this conversation, I think, right? Did I do it? Did I? Yeah. Oh wow. Strange behavior. So as the conversations goes on, the URL changes. So well, I saved the header of the conversation. So it looks like that there's this argumentation of what has what makes sense to deploy, and this guy Stephen Rose is saying that maybe CTV is not enough to, let's say, optimize the expected quantity of changes when using a soft fork. Therefore, he's saying that in his opinion we should also enable check sig from stack, so we basically make the best use possible of space for the next soft fork. And also he would then focus on the great script restoration, and after that he will upgrade CTV with TX hash. Okay, so this is his idea on how the community should move in implementing these new changes, these new techniques. So this is the page for CTV in Bitcoin Optech. Congestion control transactions. A spender pays a single output that uses CTV to commit to a follow-up transaction that pays multiple outputs. When the initial transaction is confirmed to a suitable depth, this can assure the parties with outputs in the follow-up transaction that they will eventually be paid. This two-step process can probably be used anywhere payment batching is an option, although it requires extra communication to receivers for them to learn that they have been paid prior to the follow-up transaction being confirmed. Okay. Then we have channel factories. Each change to a channel factory top level state requires each party to receive a unilateral exit transaction that refunds them their current balance in the factory in case other parties later become responsive, blah blah blah. So it looks like there's a lot to study even just for this single opcode. However, I don't want to deep dive immediately only in this one, because I want to have to proceed having like the wider picture possible. So for now, I accept to understand that this new operational code gives script transactions the possibility to basically check the template of a transaction and it can happen on many layers of information, like the version, log time, signature, scripts. I imagine that you can choose just a subset of this information or all of them. So these are also all the main use cases which will benefit from it. And then we have alternatives. And then criticism: not flexible enough, not generic enough, limited experimentation, commonly requires exogenous fees. And these are the proposals of combinations. Here we have some history. Okay, so during the years it looks like it has been discussed constantly. Nice, okay. Now we have this AnyPrevout, which is APO for the friends. SIG-hash AnyPrevout. SIG-hash AnyPrevout, an updated version of SIG-hash no input, is a proposal for a signature hash where the identifier for the UTXO being spent is not signed, allowing the signature to be used with any UTXO that is protected by a similar script. So, for example, if one guy has several UTXOs under the same public key, I mean, not public key, but yeah, UTXO that can be used by the same private key actually. Well, in that case, one can pre-sign a transaction without specifying which UTXO has to be used, and then when wanting to actually execute the transaction, in that case it's possible to choose between all the UTXOs that can be used with that transaction. So then it's possible to basically choose and create several transactions, several new transactions for all the outputs that can be unlocked with that signature. So it's thought as an alternative to CTV, but it's a really weak one. It's a really weak alternative to CTV, as it requires to do something which is not really secure, like storing signatures and precise transactions. So it's not the best for transaction templating. It's better for use cases like L2, which is a more efficient Lightning channel update mechanism. Let's just have a quick look at this. And then this. So the use cases will be like L2 LN symmetry is a proposed enforcement layer for LN that allows any later channel state to replace any other channel state. Although L2 can be used with a penalty mechanism similar to the one used with the existing LN channels, L2 doesn't need the penalty mechanism in order to be secure. In L2 is used If L2 is used without a penalty mechanism, there's no harm in publishing an old state, except that it costs transactions fees to publish. This makes it less dangerous to try to restore an LN node from a backup after a sudden failure or some other problem. It also makes it much simpler for 3 or more parties to open a single Lightning channel together, enabling features such as channel factories. Another consequence of LN channels without penalties is that LN nodes using L2 only need to store the latest state. For certain devices that lack large amount of persistent storage, they may not be able to store enough data to effectively use penalty-based LN, but as long as they can store a few kilobytes, they should be able to use L2-based LN. So I'm not really educated about Lightning. However, I know that in managing the channels, when you open it, both parties have to set aside some liquidity. This liquidity is in a multi-sig transaction, which will take all the liquidity from the first party which states an obsolete state of the channel. These statements are made in the messaging transactions which happen to manage the channel. So if a node has some problems, or acts in a malicious way, not having the current state of the channel in memory will imply some penalties, which means taking all the liquidity from that party. So parties involved in Lightning channel have to be like maniacs about backing up the channel state and being up to date all the time, so they don't incur in penalties. Therefore, when something like a failure happens, most of times I'm not sure about this, but I think that most of times the Lightning node runners will prefer to force close or do something like unilateral closure of the channel. If I'm not wrong, they do this. This means that they get back their liquidity without, continuing to stay in a channel in which they have potentially the possibility to state an obsolete statement. Yeah, so therefore all these things make channels fragile, and also they exclude Lightning node runners which do not have a lot of memory, and L2 will be a way to resolve this, because it will avoid all these statement memorization necessities. So L2 will be possible if SIG hash any prevout could be deployed. Okay. Therefore, the major impact that any prevout will have will be enabling L2. Then also enabling state chains and space chains, which are here as use cases. I will just briefly read the introduction. A state chain is a sequence of holders that succeed each other in owning the same UTXO while it sits in the blockchain untouched. It basically works by making that UTXO be redeemable by two keys, one controlled by the current owner and the other by a state chain entity. And a semi-trusted server. Okay, transfer happened by the current owner sending their key to the next and notifying the state chain entity that the transfer took place. The thing that is being transferred is called a state coin. Unless the state chain entity colludes with one of the previous owners of the state coin, it cannot steal the UTXO. Mercury layer is an improvement upon the idea that makes it even more appealing by switching the key shards controlled by the C and the current next owner on every transfer. Okay, I don't want to delve into this, but it's nice to have an idea that this exists. So it's an idea from 2019. Space chains are models for creating blockchains that attach themselves to Bitcoin through a blind merge mining mechanism that doesn't require Bitcoin miners or nodes to be aware of the existence of these blockchains. They just see normal Bitcoin transactions that may overpay in fees and include these in their blocks. Space chains can be used to emulate all kinds of protocol that require a blockchain, like protocol for transferring fungible and non-fungible tokens, open decentralized DNS replacements, single-use seals, and other ideas that involve ownership and require double spend protection. Many of these ideas have been tested already in altcoins, but invariably these include a native currency to be mined or staked in order for the blockchain to be operated, which inevitably perverts the incentives and plug the usefulness of these ideas. So APO or TX hash will enable this type of mechanisms. However, we'll not delve into it for now. So here we have the SIG hash anyprevout website. Wow, so cool. I don't know, I like the structure, like this blackness. So SIG hash anyprevout is a soft fork that allows a transaction to be signed without reference to any specific previous output, such that any output with a matching signature can be dynamically added later. Nice, clean. So there are two main super powerful things you can do with this BIP that you cannot do otherwise. L2, which we have seen just now, and covenants. Get the updated BIP merge, have the benefits of and trade-offs of the change explained in clear form and acknowledged by anyone, get working code for it, make a testnet. Who knows what has to happen for something to be soft forked in, but let's hope at this point miners will push for it themselves. A scheme that fulfills Satoshi's vision of n-sequence by allowing peers to exchange precise transactions off-chain with increased sequence numbers such that only the latest one can be published to the chain. Okay, so we have an idea about any prevout, about CTV. So CTV is the possibility to check the structure of a transaction and see if it respects a template. Any prevout is the possibility to create a transaction without immediately specified inputs. Sorry, yeah, like without UTXO as inputs, so just signing it and specifying the UTXOs later. Let's have a look. Let's have a quick conversation with an LLM about BTC CTV and any prev out. Explain them to me in few words and highlight CTV is a proposed soft fork that introduces a new opcode. It allows a Bitcoin transaction to commit to a specific template of how its outputs can be spent, think of it as a way to predefine the structure of future transactions. Use cases include congestion control, so batching lots of future transactions in 1.3 vaults, secure storage with time-locked withdrawal paths, payment pools, shard, UTXO with defined withdrawal rules. CTV is simple, limited in scope, and improves efficiency and security for advanced use cases. AnyPrevout, also known as C-hash AnyPrevout, is a proposed change to Bitcoin signature hashing behavior. It allows a signature to commit to the output being spent, but not commit the exact input transaction. So I pay $50 to Bob, but I'm not specifying with which UTXOs. This makes it possible to sign transactions that are valid for multiple prior transactions, as long as they share the same output script. Use cases include L2 and more flexible layer 2 protocols. So AnyPrevout enables non-interactive updates and better off-chain scalability solutions. Instead, CTV improves efficiency and security for advanced use cases. Okay. How can AnyPrevout be used as alternative to CTV? Specifically, I am not sure how APO can actually predetermine a transaction template. Sorry, my guest is kind of noisy. What's happening? You don't like covenants? You're not a supporter? Is this a knack? Do you have an argumentation for this? No? Well. Let's break it down. So, deterministic templates. CTV commits to a transaction template. That means you define exactly what the future transaction must look like. Then the hash of the template is logged into the script. Spending the UTXO must match that template. It's enforceable on-chain by consensus. This is not interactive and safe. Non-interactive and safe. You can send funds to a CTV vault and walk away knowing it can only be spent in a particular way. Flexible commitment. AnyPrevout changes how signatures work. Normally, a Bitcoin signature signs the input out point, transaction ID plus V out, the whole transaction structure. With APO, you can omit the previous TXID and omit parts of the transactions, like inputs. This lets you create a signature that works with many possible previous transactions, sign a transaction template off-chain before the funding transaction is even created. Apple doesn't enforce templates on chain. It only allows pre-signed transaction to be used later once the right prior transaction is found. Enforcement happens off-chain via protocol rules. Imagine a vault scenario. You prepare two transactions off-chain. A delayed withdrawal goes to cold storage after 3 days. A cancel path goes back to the hot wallet if signed quickly. You sign both transactions using APO before broadcasting the funding transaction. Once the funding transaction is live, those signed transactions become valid paths. No need to resign. This looks like CTV commits to future paths, but APO only works if users pre-sign and coordinate off-chain. APO doesn't lock funds to a path, it just makes that path available. Okay. So enforces on-chain template, requires pre-signing, interactive use, more flexible for contracts. So, okay, I have an idea about these two now. Now we have this other opcode, which is checksig from stack. It's an opcode on Elements project-based sidechains that is sometimes proposed for implementation on Bitcoin directly. The opcode allows checking whether a signature signs an arbitrary message. The opcode takes three parameters: a signature, a message, and a public key. Bitcoin's existing signature checking opcodes, such as checksig, don't allow specifying an arbitrary message. The message they use is derived from the transaction executing the signature checking opcode. This allows them to verify that the signature matches a certain public key and that the private key used to generate both of those objects was used to authorize the spend. That mechanism is powerful enough to secure Bitcoin UTXOs, but it precludes using digital signatures to authenticate other types of data in the Bitcoin system. The ability to use OPCSFS to verify an arbitrary message can enable several new features for Bitcoin users. Therefore, the current state on the Bitcoin blockchain is that we use opchecksig to check if there's a match between the signature, a certain public key, and the signature, and a certain public key, and that the private key has been used to generate both the authorization to spend and the public key. Okay. So it's restricted only to this mechanism of signing, checking the signature, and the correspondence between a public key and the private key, which can authorize the spending of a certain UTXO. I'm not sure if I expressed it in a clear way. However, my mind is clear. I will for sure train myself to express it in a better way. However, with OPCSFS, we would have the possibility of checking on generic messages which are not so we'll not be able to only check if a private key really corresponds to the public key and all this circle of checks, but we will be able to paying for signatures to do things like paying for signatures. If Alice controls a private key that can sign a transaction paying Bob, Bob can use OPCSFS to trustlessly offer to pay Alice for the signature he needs. Paying for signatures. This is not clear to me. I already tried to understand it, but what the fuck, man? This is so bad. Sometimes it's really not clear chat. BTC opcode CSFS use case. Explain them to me. Traditional object SIG verifies a signature against the current transaction. Okay. OpCSFS verifies a signature against an arbitrary message, not necessarily the current transaction. This is important because it separates the validation of a signature from Bitcoin's transaction context. Use case: paying for signature. This is the core idea behind protocols like BTVM, covenant emulation, and advanced smart contract scheme. In Bitcoin today, you can't directly pay someone just for providing a valid signature of an arbitrary message. With CSFS, you can construct a script that requires a valid signature over a predefined message. Takes a public key, signature, and message as inputs. So the BTC is not spendable until someone provides the correct signature. The signer gets paid only if they sign the right message correctly. So Alice wants Bob to sign a message, which may be a contract. Alice creates a Bitcoin output locked with a script requiring Bob's signature on a specific message and verification using CSFS. Bob sees the transaction and signs the message. He spends the output by providing the signature and gets the BTC. No trust is needed. Bob only gets paid if he provides a valid signature. Alice cannot cheat him, and he cannot get paid without doing the work. Okay, so it's really, simple, like conceptually. Of course, implementation is another word, but you pay someone to sign something. So you pay someone to, in order to sign something. Imagine you put $100 in a lockbox and say whoever can prove they signed this contract gets $100. Trustless signature bounties. You don't have to trust the signer. The script guarantees they only get paid if they sign the right thing. On-chain proof of off-chain decisions. Signatures can represent votes, approvals, attestations. Foundation for BitVM Covenants DLCs. So the message can range from a plain txt to BTC transaction. It's another BTC transaction, right? Explore for me the idea of paying someone in order to sign a BTC transaction. So you want Bob to sign a specific transaction and you're willing to pay him for it, but only if he signs it. This could be useful in many scenarios, like Bob is a co-signer in a multi-sig wallet. Bob is an oracle that needs to authorize the transaction. Bob is a miner or a validator approving a settlement. Bob is a delegate in a federated system. So this is like notary. Wow. No need for escrow or third parties. Explain me how this will be useful in BitVM use cases. BitVM is a proposed Bitcoin virtual machine that allows arbitrary computation to be verified on Bitcoin. Prover claims they executed a computation correctly. A verifier can challenge incorrect results. Disputes are resolved on-chain by stepping through a computation trace. Where CSFS comes in, so BitVM needs to verify digital signatures over arbitrary messages. A step of a computation trace, a hash of the output of a function, a claim about an off-chain event or state. It only allows spending if you sign this arbitrary message. Paying for proofs. So Alice wants to verify a computation. Bob, the prover, claims he has the correct result. Alice posts a bounty. You receive X amount if you provide a valid signature attesting to Y. Can challenge the dishonest prover. The challenge includes a new message. Step 37 of computation trace is invalid. The prover is now required to sign a response to continue. If they refuse or sign incorrectly, the challenge wins. Hmm. Okay. I sincerely, I'm not getting every detail, but for now, I'm okay with this. If the same pub key and signature pair are valid both for OpCSFS and ObjectSig, then the contents of the arbitrary message passed is identical to the serialized pending transaction. This makes it possible to put a validated copy of this pending transaction on the script evaluation stack where other opcodes can run tests on it in order to enforce restrictions on the pending transactions. Sorry. Proposals to add OpCSFS to Bitcoin are often combined with proposals to restore the opcat code removed as part of the response to the value overflow incident. This opcode concatenates two elements appending one to the other. This makes it possible to construct a message such as serialized transaction by appending together individual parts of the message. Initializing the stack with the message already split into parts simplifies the writing of scripts that perform tests of those parts. Okay, now I have an idea about check sig from stack. Anyprev out and CTV. Now let's have a look. TX hash, transaction hash. This proposal originated on the Bitcoin Dev mailing list where it was combined with checksig from stack to form an alternative to the combination of check template verify and APO. So for more on the combination of TX hash with CSFS, check cat, which we already have in the next tab opened. Now the TX hash opcode and check TX hash verify. These opcodes can be considered an upgrade of or generalization of check template verify, and thus a way of enabling advanced transaction templating. Whereas CTV allows a user to commit to an entirely pre-specified pending transaction of a certain transaction output, TX hash allows the user to specify a range of individual bits of the pending transaction to be included in transaction template. The added flexibility solves a range of the difficulties that protocols face when using CTV, for example, related to paying fees for the pre-specified transaction. But it also enables additional independent use cases like equality checking of input and output values or script pub keys. So a beep of the opcodes in this proposal is currently in draft status on GitHub. So let's have a look. Steven Rose. I thought it might be valuable to keep track of actual semantic changes being made since the initial out of draft version, blah blah blah. Okay, so this is being discussed here. So the specification for this proposal defines a construction called TX field selector that can directly be adopted to implement other construction like optx and opcode for generalized introspection or a new schnorr sig hash flag. For use cases that are enabled in this proposal, we refer to more general use cases page, transaction templating, and on the summary table. For usage of optx hash together with some other opcodes, we refer to the cat proposal page. So I want a quick confrontation BTC, CTV, and TX hash. Define and compare the opcodes. Okay. CTV is a proposed opcode that would enable a new type of transaction called mempool optimized transactions. CTV allows users to create transaction templates that are more efficient, especially in terms of transaction batching and efficient fee management. Specifically, it allows for the creation of a template transaction that can later be finalized and broadcast to the Bitcoin network, reducing the need for remining the same transactions. When CTV is enabled, it allows transactions to specify the format for future transactions. Okay. And it enforces that future transaction conform to this template. These can be used for creating more predictable and less wasteful transactions. CTV's primary aim is to enable more efficient and secure transaction types, including the ability to batch transaction, reduce on-chain congestion, as well as to improve transaction privacy by making templates difficult to reverse engineer. TX hash, transaction hash, is a unique identifier that represents a specific transaction on the blockchain, and it is generated by hashing the transaction data using SHA-256 twice and serves as a way to reference and verify a specific transaction. TX hash allows nodes and participants in the Bitcoin network to quickly locate a particular transaction. So TX hash acts as a fingerprint for transaction. It is used in Bitcoin network to reference transactions that their inclusion in blocks and blah blah blah. TX hash ensures that a transaction can be uniquely. I think that this is out of. So let's go. TX hash, optx hash. And op check template verify. Please confront them. In particular, how can optx hash be an alternative to opctv? If you just need to enforce that a transaction with a specific hash is used, OPTX hash could be used to check the hash of the current transaction against a known value. This would be a simple use case compared to OPCTV. You can think of it as ensuring that a specific data is being used, but it doesn't enforce the broader structure of the transaction in the same way OPCTV does. Okay, now explain to me this paragraph, which sincerely looks like having different point of view. In terms of how it allows for more granular control over which parts of a transaction need to be pre-specified. Let's break down. So CTV allows the user to commit to a fully predefined transaction. This means that the entire structure of the transaction is locked in advance, including in simple terms, CTV sets a template that the transaction must strictly match in order for the funds to be spent. This makes it very useful for cases when you want to verify specific condition, like ensuring that the transaction always uses certain outputs. Imagine you want to lock your funds in such a way that they can only be spent by a transaction with a specific structure. TX hash allows specification of individual bits of the transaction. In contrast to CTV, doesn't lock the entire transaction structure upfront. Instead, it gives you granular control of specific parts of the transaction, such as its hash, input, outputs, or other parameters. The individual bits here refer to selecting specific details of the transaction that you want to specify or check. For example, you could say, I want to come into the transactions hash, but I don't need to predefine everything else, such as the exact amount of or addresses of the outputs. This means flexibility. With OPTX hash, you're not committing to a rigid, fully predefined structure. You can specify a range of transaction components to match or leave some parts flexible. Example, you could require that the transaction hash matches a specific value. Ma puttana, madonna che spavento. Fucking hell. Oh shit. It's so scary when it happens. Fucking cables, I hate them. Solving difficulties with fees in CTV. Fees can be tricky in fully predefined transaction like CTV. Since CTV locks the transaction structure in advance, it could be problematic if you need to adjust the fee or handle changing network conditions. With TX hash, because you're not rigidly committing to the whole structure, it's easier to adjust the transactions fee dynamically without breaking the structure of the contract. This is because you're only specifying the transaction hash, and that could allow for more flexibility when handling fees changed. One of the additional advantages of TX hash is the ability to enable use cases like equality checking of input and output values or script public keys. This refers to checking whether certain components of the transaction are equal or match specific criteria. How does OPTX the hash of the current transaction? you sure, man, that this is what this does?
Hey, what's happening there? What's happening? 10 minutes more.
I'm not sure that OPTX is just returning that. I am not sure how OPTX hash is allowing you to specify a part of a transaction. I am not getting it, as you say that this opcode is returning the hash of a transaction, but how is that locking a specific field of the transaction? Is a relatively simple opcode that when executed returns the hash of the entire current transaction. This means it places the transaction hash on the stack, allowing the script to reference that hash. However, OPTX hash doesn't allow you to specify individual parts of the transaction. It only gives you the hash of the transaction as a whole. So it doesn't lock or specify any part of the transaction structure. It simply returns the transaction hash. Where the confusion comes in, the paragraph you quoted seem to be mixing concepts that TX hash allows you to lock parts of the transaction, but in reality, it only gives you the hash. How does OPTC? No, man, I don't like this. OP code TX hash. Man, they're not doing it right here. Proposal for new TX introspection opcodes. Check TX hash verify. Okay, so TX field selector is necessary because you take the TX hash and with TX field selector. So we have this TX field selector, which I'm not sure what's this. Let's have a look. TX hash and check TX hash verify. Okay. Your common reach the point of maturity. Both TX hash and check TX hash verify have different behaviors on the stack because of differences between legacy script and TypeScript. For the purpose of this article, these differences are not material, so we are simply going to ignore them. TX hash is a supercharged version of CTV that lets you pick and choose exactly what pieces of a transaction are constrained and must be spent in exactly predefined way, and which pieces of a transaction can be whatever someone wants at spending time. It gives you the best of both worlds, requiring something to be done when spending a covenant restricted coin, but then allowing user to do whatever they want with the rest of the funds and available to them on the transaction they're crafting. CTV simply uses a single hash of the predefined transaction in order to verify its spending time. With TX hash, you need a way to communicate what pieces of information that hash is committing to and what pieces of information it is not. So TX transaction field selector is essentially a series of bytes that can be variable in length, with each bit communicating what field in a transaction are committed to by the hash that will be verified against. This allows you to select specific field on the transaction and log time version, etc. It lets you select specific fields of the inputs and outputs, include or not the sequence number or the previous output ID, blah blah blah. The outputs, whether to commit to the script. You can also decide exactly which outputs and inputs this restriction apply to. What is TX hash useful for? Okay, so there's a good article about this. Okay, then we have this BIP. Okay, nice. Therefore, now we have an understanding that the specification for this proposal defines a construction called TX transaction field selector that can directly be adopted to implement other constructions like op transaction, opcode for generalized introspection, blah blah blah. Okay, now TX hash is involved in this other covenant all the things. CAT is a proposal to collectively enable a set of independently specified opcodes. That together enable a very wide range of use cases. The idea is to provide very raw and simple building blocks that can be used by developers to build use cases instead of focusing on use case specific opcodes. The different parts of CAT are the following: OP transaction hash, OP CAT, an opcode that concatenates stack items, OP check sig from stack, and opcode to tweak a public key with a scalar, like either OP tweak or OP tweak verify. An extended version of CAT can additionally include the following: OPTX and 64-bit arithmetic opcodes. Okay, so this will be a different approach to deploying covenants techniques to the network, and it's basically proposing to consider these single building blocks as deployable all in parallel, forming this covenant all the things. So instead of focusing on single case specific use cases, to have a more holistic approach, providing basic building blocks that combined can allow developers to represent all the use cases. So interesting. At this point I will close the study session for today. As usual, I'm really happy if you had any help watching this video, and well, I will continue my studying and I will continue sharing it. So see you in the next video if you want.